Hey everybody, Trey here. Back with another forecasting video today. We've got a complex severe weather setup on tap for this afternoon. We've got an enhanced risk from central to southern Oklahoma, and then a separate enhanced risk from eastern Texas in down through Louisiana, with a slight risk surrounding that area. Very complex setup, as we said. Multiple target areas we've been watching throughout the week. This first one is kind of here in the far southeast Texas panhandle, northwest Texas into southwest Oklahoma. That is the target I've got my eye on for this afternoon. But there's also a target here from northeast Texas down through the I-35 corridor into western Louisiana, kind of the open warm sector target. The wind shear profiles are a lot stronger out here than they are back in the southwest Oklahoma target, but storm mode concerns may hamper that target this afternoon. Then kind of this third target here along the dry line. Models are not too gung-ho on this dry line target, but there is a possibility for storms to fire if the cap can break down here, and if they can get into kind of this better sort of better wind profile area here from the I-35 corridor eastward, we could see a tornado threat this evening, early evening as well. So let's go ahead and get started here. We have got our water vapor imagery up here first. The sun's not quite up out here in the western half of the U.S., so this kind of helps us see where our main features are. And you see this kind of dry air here, this kind of dip in the dry air there with a lot of moisture out ahead of it. That is our main weather maker for this setup. A nice mid-level trough here moving east throughout the day. And let's go ahead and zoom in on our target areas for today and take a look at the visible satellite. And you can see we've got lots of low-level moisture here, lots of low-level clouds across Texas into Oklahoma, with some of these high-level clouds streaming to the northeast as well, kind of ahead of that trough. But you can see the lower levels are moistening nicely. If we take a look at our surface map, we've got 60s dew points here. Let's say go just north of Del Rio, and then kind of up and over here through central Texas, north of the Austin area. Actually kind of goes up here almost toward the Waco area and over, and then kind of dips back down here. But these are our 60s dew points down here. Those are going to be streaming northward as the day progresses. As that trough moves across the Rocky Mountains, we'll get surface cyclogenesis out here. There's already kind of a weak representation of a surface low out here. You can see this kind of broad sort of cyclonic flow, broad sort of surface low here. As that trough continues to move eastward and traverse the Rockies, we'll get that cyclogenesis here in eastern New Mexico. That low will consolidate and move eastward, and as that happens, that moisture is going to be drawn in, and we'll see the surface low kind of positioned somewhere out here by early afternoon and evening. And so let's take a look at some soundings across the region. Unfortunately, we don't have a Norman, Oklahoma sounding this morning, but here's our Dallas-Fort Worth sounding. You can see it's kind of cool at the surface, 60 degrees here at the surface. A little bit of elevated instability, kind of capped here at 700 millibars. This kind of EML, and if we go toward the west, here's Midland, Texas. You can see very steep lapse rates aloft, very steep elevated mixed layer here across this with westward extent, but already some elevated instability. That cap is going to take quite a bit to break here across Texas. But out here over Louisiana, this is Shreveport and East Texas, not quite as pronounced of an elevated mixed layer. So I would expect that storms are going to fire a lot earlier out here in central Texas, given just the overall timing of this trough. We'll take a look at where it is now, and that is not going to work. Something is up with the SPC 500 millibar map here, but the axis is over here across northwest Mexico. And it's going to move fairly rapidly to the east. And if you notice here, let's go down to 700 millibars. You see this kind of kink in the flow here across southeast New Mexico, West Texas. That is going to move east throughout the morning, and I think by late morning, maybe lunchtime, this perturbation you can see there across central and north central Texas into the Panhandle, that is going to kick off storms out here in this region, probably the I-35 corridor, central Texas, and those are going to move eastward. And given the lack of overall capping out here that should erode as the main trough impinges on the area, we should get a lot of storms to develop out here in central Texas and move eastward into northeast and east Texas. So early initiation and sort of clustering of storms probably is going to favor more of a sort of heavy rain and damaging wind threat as they congeal throughout the day. But our low-level jet is a lot stronger out to the east. You can see it's over here now. Very strong low-level jet here from southern Oklahoma into central Texas. We saw kind of the reflection of that given on the satellite. All those low clouds streaming northward and northeastward on that low-level jet. So rapid moistening is taking place across this region. But you'll notice throughout the day it kind of wanes. And we have sort of the secondary lobe out here across the sort of Houston-Galveston area. That is going to strengthen out here as we go into the early evening hours. And any discrete storms out here will have a tornado threat given the degree of shear. And we'll take a look at that in a minute with some of our forecast soundings for today. But this low-level jet going to be moving off to the east. And so shear profile is not going to be as strong out here for the southwest Oklahoma target. We're going to have to rely on the cold air aloft from this trough. You can see that the center of the trough, the axis of the trough in eastern New Mexico in about 6 hours, so early afternoon. So by early evening, late afternoon, early evening, the trough axis will kind of be out here in the Texas Panhandle, so we'll be under the influence of that really cold air aloft. And these red dashed lines are our temperature lines right here. And you can see, if we get the pen out here, you can see minus 21 degrees out here across New Mexico, minus 20. So very cold air aloft associated with this trough. And as the trough moves eastward, those cold temperatures will move eastward as well. So we'll have this really expansive plume of cold temperatures out here that's going to really crank up that instability. And we should see more sunshine out in this area. We saw in our satellite view that it's very cloudy out here. That may persist throughout the morning, but you can see some sunshine back here in the western Texas Panhandle, Texas South Plains. That should move into the northwest Texas area, southeast Texas Panhandle by afternoon. So we should have a lot more clearing out here to get our low-level lapse rates stronger as well. And as a result, we've got large instability, large low-level instability with adequate wind shear. Let's look at our NAM forecast right here. The 12Z models are not quite in yet. So real quick, we'll take a look at the trough progression. You can see it move eastward throughout the day. And you can see the axis right there is basically in the Texas Panhandle, down in toward the Del Rio region. So let's look at temperature here, and you can see by afternoon we've got very cold air aloft. We've got minus 20, minus 21. That's going to move out here into the Texas Panhandle. That's going to help really bolster instability today. And this is really kind of a cold core. It's kind of a pseudo cold core type setup. Take a look at where our surface low is going to be throughout the day. You can see the cyclogenesis there throughout the day. We get surface low to develop, move into northwest Texas, and that will really help increase those surface winds and help draw that moisture northward into the surface low. Sort of, you see a very pronounced triple point right there. Here's our surface low, and you can see all of that moisture streaming in to that surface low there. Here's our dry line down here, but this triple point is what's going to help initiate storms this afternoon. I think somewhere maybe in the Turkey, Texas area. And as that happens, they will quickly become supercells given the very cold air aloft, very unstable profiles out here. If we take a sounding, we'll take a sounding at 21Z here, right along that triple point. And you'll notice it's going to be a very unstable profile here. Lots of instability, off over 2,000 sort of mixed layer cape here. A little bit of capping inversion left, so storms may hold off a little bit more. Out here we did see on our soundings the cap sort of increased with westward extent. So that triple point is really going to be needed to erode that cap quickly, and that cold air aloft going to allow those storms to really become severe quickly. Take a look at 0Z. You can see the cap is eroded. Very large cape here, 3,000 joules per kilogram of mixed layer cape, and adequate low-level shear for a tornado threat with these. And this is very sort of similar to the Springer, Oklahoma tornado day from last year, April 22nd, 2020. So let's look here. And so this is what happened almost a year ago yesterday. Couple large tornadoes happened here in Springer, Oklahoma and Medill, Oklahoma. This was a very similar event. You'll notice we had our surface low here in southern Oklahoma, sort of the warm front here. We had much better moisture quality out here for this day, but in these kind of pseudo cold core setups, you don't need lots and lots of moisture to get tornadoes out of this. And this is from a website by John Davies. He's an expert in these cold core sort of events. And we notice our surface map here, surface low. Here's our cold front sort of dry line sort of combo right here. And this very narrow region, as the moisture wraps into that surface low, is where you get tornadoes in these kind of cold core events. Now this was kind of a cold core event on steroids. And here's kind of that diagram. You see the surface low in proximity to the upper low aloft, and then you get sort of right along that warm front just east of the surface low where that moisture sort of really gets brought into that surface low. You get tornadoes right in that region, and that's what we got. We got an arc of storms right on that dry line bulge that afternoon, and we got some significant tornadoes out of it. But the hallmark of these cold core or pseudo cold core events is the low level instability. And given the amount of sunshine out here and rapid moisture transport, we should have quite a bit of 0 to 3 kilometer instability, which is a pretty significant sort of parameter for these setups. And you can see already by in 6 hours, so 19Z or 2 o'clock, we've got over 100 joules per kilogram of 0 to 3 kilometer cape out here in sort of this region. Of course, unfortunately, can't get the image to stick on this mesoanalysis page, but in this region where we have this surface vorticity right along that front, that sort of warm frontal zone, and sort of that dry line bulge, right in this region is where you see that moisture wrapping in, and really steep 0 to 3 kilometer cape coincide with that surface vorticity. So you don't need a ton of low-level shear to get the job done in these cases. You just need adequate surface vorticity, which we have here, 0 to 1 helicity, 156 meters squared per second squared. That's more than enough. And given 0 to 3 kilometer cape of 162, very, very high 3 cape, any vorticity near the surface is going to be really rapidly stretched into the vertical. And these storms will have the potential, especially as we go into early evening, to produce tornadoes fairly quickly once they tap into that better moisture here near that surface low. So regarding our northeast Texas target here, notice how that low-level jet wanes throughout the day and then really ramps up by 0Z here across East Texas, and will take a sounding. Maybe difficult to get an uncontaminated sounding out here, and you see we do have some contamination here. It's very hard to get an uncontaminated sounding out here. There's just going to be so many storms ongoing, but you can see kind of in a general sense how much better the photographs are out here, quote unquote. Very much an increase in that low-level jet. You can see 40 to 50 knots here in the low levels, really looping those photographs. But notice our instability is very much less than it is out west out here. Not quite as steep mid-level lapse rates, very meager low-level lapse rates. That may really hamper the tornado threat out here, despite these pretty nasty looking shear profiles. So That is a concern for the East Texas target. Just an overall lack of instability, particularly low-level instability. We may not get these clouds to burn off quickly enough, and then once we get a lot of storms to fire, there may not be a chance for much destabilization to occur. So even though these shear profiles are a lot more nasty out here in East Texas, I don't think the tornado threat is going to be as big as it might be if we had more destabilization. You can see that low-level jet really ramp up by 3Z, and the hodographs are really going to get big here just after sunset. You can see that, but we just don't have any instability out here to support supercells. So that is a good thing given these wind profiles. 0 to 3 helicity, 1,000 meters squared per second squared. That's just insane, but no instability to support supercells, and that's going to be a good thing out here. So a lot of storms, heavy rain, lots of thunder, but tornado threat looks to be pretty low out here. But overnight, we should, as these storms kind of congeal and move off to the east, there will be sort of the squall line that happens, but that will eventually sort of outpace the instability and die off in the early morning hours, I would think. But once again, focusing on this target, you notice this low-level jet out here across southwest Oklahoma, not your typical sort of low-level jet you like to see. But again, you don't need massive shear in these kind of pseudo-cold core setups to really get tornadic supercells. So something to keep in mind. And last year, so let's take a look a little bit closer at this sort of Springer event and compare it to what we're seeing this year, because this event is very, very similar. Let's see if they've got the 500 map fixed. Unfortunately, they don't have the 500 millibar map fixed here, so let's go ahead and go to the upper air maps here. We'll go to 12Z 500 millibar map. So here you go. Here's our 500 millibar map for this morning. You see our trough out here over Arizona and northwest Mexico. And then let's take a look at our trough from last year. You can see this is at 12Z, April 22nd, 2020, the Springer day. You can see very similar setup, just a little bit farther to the east, our trough axis is. And as we go throughout the day, we see that trough kind of open up, and by 21Z, we have this sort of kind of positively tilted trough almost in our target area. And, of course, we like to target the exit region. That's where vorticity is maximized. That's where lift is maximized. So there was a warm sector target that day as well, produced some pretty destructive tornadoes out here in East Texas into Louisiana in the early evening hours. But out here, you wouldn't expect to look here at first glance. And we can compare that to today's 500 millibar pattern. And we'll go to our CONUS view. We'll go to 21Z today as well. And you can see, similarly, that trough really starts to impinge on the target area. And then as we go toward 0Z, it's almost right on top of our target area. We're kind of under that cold pocket aloft by 0Z. You can see that the trough axis right over Oklahoma there. I think the storms had fizzled out by this point, but nonetheless, you had your best flow off to the east and south, and we're kind of under that cold pocket aloft. And let's kind of compare the soundings from that day in proximity to the Springer and Medill tornadoes, and then the soundings we're seeing today. So let's go ahead and go to 0Z right at that triple point. And so this is a RAP model sounding in proximity to the Springer and Medill tornadoes. You can see very, very large CAPE. We had 2,000 to 3,000 joules per kilogram of CAPE, mixed layer CAPE that day. But notice our hodograph is not really a typical hodograph you'd expect, strong tornadoes with. Not a whole lot of curvature in the lowest levels, fairly straight overall. And we go to our event today. Very large CAPE, and not a whole lot of turning in the low levels. We don't have that influence of the low-level jet. Fairly straight hodograph overall. But notice our 3 CAPE, 156. That is anything over 50 is what I look for adequate 0 to 3 kilometer instability for these for supercell events, for supercell tornado events. We've got 156. That is big time 3 Cape. And if we go to our RAP proximity sounding 3 Cape, almost 200 joules per kilogram of 3 Cape here. So we had ample instability in the low levels, and what that does is it helps stretch any sort of spin in the low levels. Any vorticity in the low levels is rapidly stretched into any updrafts that coincide with that vorticity, and as a result you can get supercells and tornadoes to happen rapidly despite the sort of narrow parameter space, narrow sort of spatial window for supercell tornadoes right next to that low, as well as the kind of narrow parameter space we have here that you wouldn't expect strong tornadoes with. And by the way, this is from ustornadoes.com, an excellent database of these modeled soundings near these famous tornado events. Shout out to Cameron Nixon for this really awesome database where you can look up these modeled soundings. But once again, you can see a lot of similarities between the Springer event, given the overall sort of synoptic pattern, and then these sort of soundings. You see kind of the exact same thing. Not a lot of low-level shear, but it's enough. And when you have ample low-level instability like that, any shear near the low levels, if adequate, will get stretched upward, and you can get pretty quick tornado genesis out of these storms in this sort of pseudo-cold core regime. So let's close things out here by looking at some cams. Finally, this is the 12Z HRRR run. And you can see by 18Z, 1 o'clock, we've got just a lot of storms starting to fire in central Texas. So not really going to have enough time to destabilize, get those low-level clouds out. And so instability profiles out here are going to be very weak. That's why you see pretty quick clustering of these storms. Nothing really looks isolated at all. Very, very messy event. But by late afternoon, early evening, we start to get supercells to fire along that triple point, kind of in the Memphis, Texas area. We'll take a modeled sounding here near those storms, and you can see that might be a little bit behind. We'll go just ahead in southwest Oklahoma. You can see 73 over 60, large instability here. Once again, our shear profile is not that strong. Overall, sort of straight photographs, not much curvature. But we do have low-level shear in place, and that will only increase as we go into the early evening hours. This is at 0Z. You can see we do have some modest, that looks to be a little, maybe a little off. Maybe we'll go just ahead. Once again, you can see a little bit of an increase in the low-level shear there, and with ample 3 Cape in play. A little bit contaminated here, but the overall message is that we're going to have large instability, large low-level instability with enough low-level shear here to, I think, produce, to have these supercells stay isolated and produce maybe a tornado or two, at least through the first few hours of their life cycle. With time, they will sort of congeal as we get storms here along this sort of differential heating axis up here in northern Oklahoma, and we'll kind of get this congealing sort of MCS as we go throughout the evening. You can see that the storms down here stay really messy. There are some sort of embedded helicity tracks out here into Louisiana, but overall, very, very messy event out here, despite, once again, those massive shear profiles. Let's see. I don't think the 12Z, these cams are in, so we'll take a look at 0Z last night, just to kind of get a picture of what these were showing. This is the WRF ARW model. And it really kind of showed the same thing last night, a messier mode. Maybe some attempt at discrete storms out here in East Texas early on, but kind of the same thing. We get isolated supercells to form here in southwest Oklahoma by late afternoon, early evening, with definitely a tornado threat, as well as a large hail threat, maybe a significant hail threat throughout their life cycle, given the fairly isolated nature of those storms and the steep lapse rates aloft. This is the NSSL WRF model, same thing, lots of storms fire by midday. We get this isolated supercell or two to fire here once again. So very good agreement amongst the models about the sort of evolution of this setup. Very messy mode out here despite the greater shear in East Texas. A sign of kind of isolated, more isolated, lower shear but larger instability setup out here that may compensate for that lower shear. This is a fairly sort of classic cold core profile and not really a cold core, true cold core type event. As far as chasing goes today, I would definitely target this setup out here. Now, we talked briefly about the dry line down here in Central Texas firing up. You can see we have adequate moisture up here, but once again our capping was a lot stronger out here with western extent, and without the influence of that triple point where you have enhanced convergence, we may not see, and given that the trough, the exit region of the trough has kind of passed by this region by this point, we may not get enough. Well, okay, so this is interesting. The NAM, 6Z NAM has a lot of instability here. 255 3 cape. Wow. That is a lot of instability in the low levels, and over 3,000 joules per kilogram of mixed layer cape here. So shear may not be adequate here since we're kind of a little bit removed from the colder temperatures aloft, maybe down here in Central Texas. But given this profile, I think if a storm can fire, it will be explosive, explosively develop, maybe, and definitely have a large hail threat. Maybe can squeak out a tornado if it can tap into the better low-level jet out east. We'll take a sounding just east, and you can see a little bit better hodograph curvature there. So if a storm can fire down here along the dry line, once again, I don't know if this is accurate. It might not have as strong of a cap out there. We see a pretty strong cap, although it is breakable. Convective temperature is only 80 degrees. Will we get up to 80 down there? It is possible. So I would definitely keep an eye on that area south of Dallas as a secondary target. If we can get an isolated storm to fire down there, it would have a tornado threat if it can get into this slightly better low-level jet out here toward just east of the I-35 corridor. So definitely something to watch. Couple final things. This is the SPC guidance. This is 0Z runs, but they're calibrated sort of STP tornado product. You can see kind of that dual bullseye here in southwest Oklahoma and then out here in East Texas. And we'll look at the STP, significant tornado parameter, out here. And you can definitely see that sort of dual sort of threat out here, southwest Oklahoma into East Texas, although remember, the storm mode may be hampering that out there in East Texas. And then finally, our sort of cheat code, the significant tornado ingredients out here on the SREF. You can see it's pretty much maxed out here in East and Southeast Texas, but this doesn't take into account storm mode and the storm interactions. So you can see it does stretch into southwest and southern Oklahoma as well. So target today, I think it's a pretty clear target as far as chaseability goes. This is going to be, excuse me, your best bet down here in southwest Oklahoma, northwest Texas for a nice isolated supercell with the tornado threat and large hail. Out here, wind shear is a lot better, so if a little bit better instability is realized out here, could definitely see a greater tornado threat. But at the moment, looks like we're not going to clear out those clouds. A lot of storms are going to fire and interact, so that may keep the tornado threat down out here as we go into the afternoon. So that's all I've got for now. Kind of a longer briefing today, but this is a very complex setup. So if you're chasing today, good luck, and we will see you in the next video.